In life, parents always pray that their children and grandchildren should prosper more than they do. This kind of supplication is pointing to a mathematical idea. They are saying, in other words, that their own prosperity should be the least, while ranking that of theirs and their children and grandchildren. This is a concept of the topic of our discussion in this video, which is least common multiple. At the end of this lesson, learners should be able to find least common multiple of numbers, find least common multiple of algebraic expressions. These are the two major stated objectives for this video. I remain your mathematics instructor, Abdullah Falade. Firstly, we need to talk about multiples of number. Multiple of a number, say A, can be written in this form. So it's going to be written like a span of A. So these are the symbol of multiple of A equals. It is a set AK such that whenever you see this line, it means such that this K belongs to set of positive integers. So meaning that the number in consideration, if I'm finding the multiple of 3 now, for instance, if I'm finding the multiple of 2, I will have 2k, such that k comes from the set of integers. So it means when you're finding the multiples of 2 in the simple man language, just start multiplying 2 by 1, 2 times 1, comma, 2 times 2, which is 4, comma, 2 times 3, which is 6, comma, 2 times 4, which is 8, comma, 2 times 5, which is 10, comma, 2 times 6, which is 12, comma, 2 times 7, which is 14, and on like that. So it is infinite. It continues like that. Looking at the multiples of 3 as well, that is span of 3. In a Self-Boolean notation, it is written as 3k such that k belongs to a set of positive integer. So this means in a simple man language, in a layman language, we can say 3 times 1, which is 3, comma, 3 times 2, 6, comma, 3 times 3, comma, 3 times 4, which is 12, 3 times 5, which is 15, 3 times 6, which is 18, and on like that. The same thing with multiples of 5. It is written as 5, a set of 5k such that k belongs to set of positive integers. So that is 5 times 1, 5, 5 times 2, 10, 5 times 3, 15, 5 times 4, 20, 5 times 5, 25, 5 times 6, 30, and on like that. Going to the multiples of 7, you can see we have a span of 7, which is 7k such that k belongs to set of positive integers, which is equal to set of 7 times 1, 7, 7 times 2, 14, 7 times 3, 21, 7 times 4, 28, 7 times 5, 35, 7 times 6, 42, 7 times 7, 49, and on like that. The same thing goes to multiples of 9. 9 times 1, 9, 9 times 2, 18, 9 times 3, 27, 9 times 4, 36, 9 times 5, 45, 9 times 6, 54, and on like that. So these are the examples of how to get the multiples of number. Now we can talk about common multiples. In this first example, what are the common multiples of 2, 3, 6? How do you get the common multiples of 2? Like we explained in the previous video, that will be 2 times 1, 2, 2 times 2, 4, 2 times. So it goes on and on. We stopped at this. We also do the same thing for multiples of 3. That's 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. We also did the same thing for the multiples of 6. We have 6, 12, 18, 24, and 30. Don't forget, the question is we should find the common multiples. So we want to look into the multiples of 2, multiples of 3, and multiples of 6. What are those things that are common? So you can see we have 2 here in multiples of 2. Do we have 2 in multiples of 3? No. In multiples of 6? No. We move on to 4. Do we have 4 in multiples of 3? No. 6 also. Do we have 6 in multiples of 3? Yes. Do we have 6 in multiple of 6? Yes. So you can see the multiples of 6 is 6, 12, 18, 24, and 30. So you can see the common, we are trying to look at the common multiples of 2, 3, 6. So if the common multiples of 2, 3, 6, we can now go further. Look at this second example. We are trying to look for the least common multiples of 2, 3, 6. And from there, from the example 1, where we are able to state out the multiples of 2, 3, 6, we deduce the common multiples to be 6, 12, 18, 24, and 30. If you look at multiples of 6, you see 6. Multiples of 3, you see 6 also. Multiples of 6, you see 6. When you also look at 12, we have 12, 12, 12. Look at 18, we have 18, 18, 18. Look at 24, we have 24, 24, 24. Look at 30, we have 30, 30, 30. So all these are part of the multiples that are common to 2, 3, and 6. And looking at these 6, 12, 18, 24, and 30, which one is the lowest? So the lowest among this common multiple is called LCM, which is the purpose of this video. So the least common multiple, the lowest among the common multiple, is 6. You can see the LCM of 2, 3, 6 is 6. An alternative method, what is the least common multiples of 2, 3, 6? The solution goes thus. So in this case, you'll be using a table form. This is the number you are trying to find your common multiples, 2, 3, 6. So you start from the lowest prime factors. So numbers that can go, the lowest prime numbers. So you can see from here that we use 2. So 2 goes in 2, 1. 2 will not goes in 3. So you will write this 3 to be 3. 2 goes in 6 3 times. So whenever the figure you are using, the prime number you are using, will not go. Whenever it's not going in any figure, you leave it the way it is. So the next thing is we want to use the next greater prime numbers apart from 2, which is 3. 3 doesn't goes in 1. You write this 3 in 3 1, 3 in 3 1. So whenever you have this 1 1 1, the uniformity 1 1 1, that's where you stopped. And the next thing for you to get the least common multiple is to multiply these figures, these prime numbers you used here, and the least common multiples of 2, 3, 6 will be 2 times 3, which gives 8. If you are watching this video for the first time, do not forget to subscribe, like, share, and comment. So let's look at another example. In this example, we are looking at the least common multiples of 10, 15, and 18. We shall use the alternative method. So we have 10, 15, and 18. So the lowest prime numbers we are using is 2. 2 in 10, 5. 2 doesn't goes in 15, you have 15. You write that. 2 goes in 18, which is 9. So the next prime numbers that can be used that will go in either of these 3 is 3. In either of 5, 15, and 9 is 3. So 3 doesn't goes in 5, you write 5. 3 will goes in 15, 5. 3 goes in 3, 9. So the next prime numbers that can be used is 3. 3 goes in 5, no, we write 5 again. 3 goes in 5, no, we write 5 again. 3 goes in 3, we write 1. So the next prime numbers we can use now is 5. 5 goes in 5, 1. 5 goes in 5, 1. 5 in 1, no, we write. And like I said in the previous example, once you have 1 1 1, that's where you stop. So to find the least common multiple of 10, 15, and 18, you multiply the prime numbers that were used throughout the table. That is 2 times 3 times 3 times 5. 2 times 3 is 6. 6 times 3 is 18. 18 times 5 it gives 90. So the least common multiple is 90. You can also use the first approach by listing out the common multiples of 10, 15 and 18, and you choose the least among them. So example 3. So in this case, we are trying to look for the least common multiple of algebraic expression 3x squared, 15xy, 27x squared, y squared. So we shall adopt the second method using of table. So the alternative method. So now you start with figure. In the case of algebraic expression, you start with figure. Whereby you start with figure, you can see 3x squared, 15xy, 27x squared, y squared. So 3 goes in 3x squared, that will be x squared. 3 in 15, that is 5x. 3 in 27, that is 9x squared, y squared. So 3 goes in x squared, no, you rewrite x squared. 3 goes in 5xy, no, you write 5xy. 3 goes in 9, it gives 3x squared, y squared. You move further, since 3 can still go here, you repeat 3. 3 in x squared, you write x squared. 3 in 5x1, 5x1. 3 goes here 1, so that is why you have a x squared, y squared. You can write 1, you can leave it, so it's still a coefficient of x squared, y squared. So the next thing is to use another figure, which is 5. So that's why we have 5 in x squared, so that gives x squared, because 5 doesn't go in x squared. 5 in 5xy, we have xy. 5 in x squared, y squared, we still rewrite this to be x squared, y squared. So the next thing, I use x in x squared will give you x in xy is y, x in x squared, y squared will only be xy squared, followed by x again, x in x1, x and y, you rewrite it because x doesn't go in y. X in xy squared, we have y squared. So the next figure, the next thing you can use now is y. Y in 1, 1, y in y, 1, so y in y squared will give you y. So the last pair we have y in 1, that's 1, y in 1, we have 1, y in y, we have 1. So in a nutshell, the lowest common multiple, which is the least common multiple as well, of 3x squared, 15xy, 27x squared, y squared will be the product of 3, 3, 3, 5x, y, y. So that's why we have 3 times 3 times 3 times 5 times x times y times y. That's where we have 45x squared, y squared. So you can see how interesting that has been. You can use the first attempt, you can use the second attempt. So exercises. So these are questions for you to practice, and you drop your answer at the comment section. So you find the least common multiple of this set of numbers, and you also find the least common multiples of this algebraic expression. Thanks for watching. Press like, share and subscribe for the next video. Bye for now.